My interesting topic is the performance analysis in the mobile application.
My name is Mark Hennessy. I'm a student at Carnegie Mellon, Silicon Valley, and my research is about making it easier for developers to work with medical standards and get a foot in the door with home health care.
Hi, my name is Soumya Samantha. I'm from the Software Engineering Institute, and I work in a group called the Advanced Mobile Systems. And basically, my interest is looking at mobile applications in a resource-constrained environment.
Martin, Chris, I'll tell you.
Sounds good. Go ahead,
Linda Northrup, Software Engineering Institute, Carnegie Mellon. I'm interested in mobile computing within socio-technical cyber-physical ecosystems, or what I call ultra-large-scale systems.
I'm Jeff Gray from University of Alabama. I'm interested in primarily model-driven research, and recently been working on using smartphones for first responders and damage tracking. For example, we have a group that may be using our technology to go to
and sorry to put you on the spot.
Hi, Reese Moore, Virginia Tech. My primary interest is in security.
Okay. And with that, I would like to introduce Martin Griss. Martin Griss is a local. I found out he's been a local for quite a long time. He's the director of the Silicon Valley Carnegie Mellon campus, and also the director of the Disaster Management Initiative, which is a really nice scenario precisely for mobile-enabled systems. 40 years of academic and industry experience, has done a lot of work in a lot of areas, very published. And you know what? I looked at your slides, and you have you can say more about you than I can. So please, Martin, get started. Thank you.
Yeah, every 5 years I either grow a beard or take it off. So it never happened. Probably represents also how I do research, so constantly trying different things. All right, let's see. Everybody online. So I'm going to try and do, really, it's more of a quick tour through many of the things we've been doing, rather than, I would say, a coherent keynote that tells you some grand vision of the future. This is our campus in Silicon Valley, and I'll talk a bit about it. So we've been in Silicon Valley since 2002. The reason Carnegie Mellon came here was in part to become part of this ecosystem that is largely dominated by mobile computing and small devices and things of that kind. So we're looking at the balance of education, research, innovation, entrepreneurship. We have a number of students. There's 180 students who graduated, over 700 alums. And we have something like 55 faculty and researchers who work with master students, PhD students, and NASA. We're located on the NASA base. In 2008, we were looking at what should be a research focus that's appropriate for us here in Silicon Valley, that would do things. We decided that mobile computing in various forms was going to grow dramatically. It actually grew faster than we even anticipated at the time. And the idea was this enriching anywhere, anytime computing. And we started off as an outgrowth of Scilab, which is a large research activity in Pittsburgh. And the idea was to prototype some novel applications, devices, and systems. And it was important, it's all three. So systems is their devices. It became clear this is multidisciplinary. You have to think about usability, application domains, networking, distributed computing, all of these things. The idea was to do holistic synergistic work. That is, use this as a device to bring multiple faculty. We were just growing at the time together around something. The idea was this is where all the original faculty were hired, and also the original PhD students. We now have 40 PhD students on the campus, and the areas have grown, but initially it was mobility and networking and security. Experimented with some pilots and created collaborative community. So since April 2008, we ran workshops and hackathons on security, mobile health, disaster management, smart grid, and various novel applications. We also helped launch a conference called MobiCase, which had as one of its goals thinking about the mobile activity, and 2 workshops on mobile software engineering, realizing that Ray said at the beginning, People hack these things together, throw them out. If you blink, they're gone, and yet there's no discipline, there are no patterns. We're wondering if the heuristic should change. How do we teach it, and so forth. So that was the context. I'll say a few things about mobility in general, and then we'll tend to focus on this one workshop area, which is disaster management. Because what happened is we were looking for an application domain that would leverage our unique presence here in Silicon Valley, our presence at NASA, and interesting. And so all of these workshops started off as small workshops like this, except this one, where the first time we ran, we had like 150 people come to the workshop. And that said, there's something there, and we said we'll create an initiative around that. So one of the observations was looking at mobile and realizing that the world is mobile. All the rest is almost irrelevant at this point. If you think about it, 7 billion population, mobile phones more than 5 billion, increasing number of them are smartphones. In the US, I think we've just crossed to 50% smartphones. And of course, interesting question, what's a smartphone? Well, that's last year's feature phone becomes last year's smartphone. SMS is the dominant communication medium by far. Although things like the mobile internet and Facebook and so on are coming up. So it says the social web is growing, it's becoming really important, but people still largely communicate by simple messaging because of the cost, ease of use, the ubiquity. And then of course you notice that the evolution of phones, they're getting smaller and smaller, and they're now embedded in everything. I mean, the Kindle that I used and bought a couple of years ago has a Sprint smartphone in it, or a phone in it, anyway, not necessarily smart. Well, you can think of the Kindle as a smartphone in a curious way. The other thing, and that led us to interactions with Panasonic, with Ericsson, with Nokia, and various others who were all moving into Silicon Valley at the time. It's interesting that they made that part of their headquarters. Ericsson moved a substantial number of people there because of the interaction with Google, with Panasonic, with Nokia, each other. It's rather interesting. So a talk that was given by someone to us from Ericsson that we've subsequently been thinking about it is this evolution of global connectivity. If you look about something happened here, started to connect into mobile, then people, but what's going to happen is things. They'll be mobile enabled. They're going to be 10x or more connected devices, which the Kindle is an example. Phones now are, they're powerful and cheap. You can stick it in a robot and use it as control. You can stick it in a satellite. And so all of a sudden, mobile devices are just components of something larger, which is back to the systems perspective. And so we get very interested in what might be called the Internet of Things, or the social web of things, or the web of things. People haven't quite settled on what you want to call it. So before I get in a little further, I just want to cover some of the research activities that came out of thinking of mobile as a driver. Because all of the stuff we did here has a large amount of mobile involved with it. But obviously mobile computing in general, and that's software engineering thereof, the application, the usability, personal systems. The thing about a mobile phone is I carry it with me all the time. It's mine. It knows about me, or could know about me. So then people are very interested in voice recognition. It's really tedious typing on these things. Wireless sensors. What else could there be in the environment that either moves around or is fixed? So this is a little helicopter that can communicate, and we think it's small enough that you can deploy hundreds of them in a disaster. If they bump into you, no big deal. Quadcopters are still too big. In order to communicate effectively, smaller and smaller antennas. So we do work on using genetic algorithms to design antennas that look like somebody bent a paperclip. It could have been, except these are very precise bends. There's a radiator, reflector. And some of these are floating on spacecraft. Some are going to be used in small devices stuck on the wall. I personally do a lot of research with my students on context-aware applications. So I'm carrying a device as I move around that knows about me, knows about the environment. I can get proactive services offered to me because it knows what's going on. And the question is, how do you write those things? So I had a student build up a project where these are like little widgets, very similar to user interface systems, where they capture various things from sensors and they combine them and do sensor fusion. Obviously, security is crucial. If it's monitoring me in a mobile health situation, I want that to be very secure. If I'm doing my banking, I want that to be very secure. That's why we grew out of Silent. Human identification, how do you authenticate yourself on your device? a lot of machine learning. If I'm doing context-aware applications, I need to figure out what I do normally and what's exceptional, so that I can do things on an exceptional basis. So we've got work in Bayesian techniques, various clustering techniques. These things live in systems. They're pouring an enormous amount of data into servers, so we do work on big data. Work with GPUs, work with cloud. Now we can think about this new term called fog computing, which is pushing the cloud into little pieces out to the edge. Work in energy, smart grid, smart energy. One of the projects we'll talk about in smart communities a little bit is how sensors in the environment can tell where people are, what lights are on, what air conditioning is running, what energy is being used, and you can save energy by doing proactive management of the energy system and of the people. So it's a socio-technical system in an interesting way. And of course, a lot of software engineering. My own area is software reuse, product lines, and the question is, what on earth has that got to do with all of this mobile space? If people are throwing apps out every 2 weeks, are those apps part of the product line, or are they just random? And Android is really a growing platform for building, if you like, domain-specific apps rather quickly. And then disaster management, which I'll talk a bit more about. So all of these things have played together, and mobile is a theme. Recently, we had something like 75 mobile phones for a class. Half of them just suddenly disappeared because they, it's just a commodity. So we can buy another 75. And we didn't used to do that with laptops. We didn't do that with desktops. But the phones are useful in their own right, and they get consumed, and people take them apart and put them into other applications. So that's interesting. And that's a phenomenon. So what do I do about the software apps that are on them if the phones are going to disappear very quickly? So now I want to talk about the disaster management initiative. So, as I said, it grew out of looking for an interesting application area for the mobile world. We realized you can apply it to all kinds of things, and we thought if we focus on one interesting domain, we might be able to build some really intensive apps and learn some of the challenges. And so we ran these little topical workshops. This one, disaster management, became exciting. We always refer to Silicon Valley or California as the Disneyland of disasters. You want to try something, we have it for you. And NASA has a large group that does disaster response and training, and so we realized if we partner with those guys and in Silicon Valley, we could do something unique. So that's what got us into the space. So in 2009, this started. We've been running workshops every year. We built up a group. One of the challenges we discovered is very hard to find funding for this space. There was just recently the tornadoes and earthquakes and things. Money comes out at that time, and it always goes into response. Or often they don't send money, they send blankets. And then everything goes quiet. People really don't like to think about preparation. They don't like to think about designing systems. And so the mental model, which we are still grappling with, is if you want to do mobile applications to support this, those applications have to be things you use every day, and then during an emergency, they suddenly have this new personality. Something you've got to download or something you have to get. It's not going to happen. So we don't really have the full answer to that. That's kind of the theme that is floating out there. Things that are special purpose somehow have to be tied to the general purpose as well. So this initiative was to look at open access, open source, interoperable systems. Because in disaster situations, strange things come together and make configurations. I don't know if you remember the big earthquake in Haiti. That was sort of the first time where large-scale mobile computing made a big difference. They announced a short code, and people communicated, but not only people in Haiti, but people outside the diaspora were able to help translate. Somebody would say, the old post office has collapsed. When you think about it, old post office, how will anybody know what it is? Because it's no longer a post office, right? It's something else. So you need people to translate that. So this became a crowdsourced, mobile-enabled social web for disaster. That was very interesting. So we're interested in the interaction between mobile, social, cloud, and sensors. Because in some cases you don't send people, or you need to send some little robot or some device. We're interested in all hazards, because the big issue in all of these disaster situations is communication and finding the essential information when there's a lot of confusion going on. And so the basis is emergency communication, and that's what we're going to talk about. We want it to be both regional community and international. It has a lot of mapping. You want to get citizens involved because when a disaster happens, who's there? It's not going to be the police and fire. It's going to be your neighbors. And how do you enable neighbors to do what's needed to be done? In the old days, people said 1 to 2 days you had to be self-sufficient. Now they say 3 to 7 days, because police forces at this time of the budgets and fire departments are decreasing in number. They typically don't live near you. You know, our fire department in Silicon Valley, unfortunately, doesn't live there. They live out near Santa Cruz and places like that. If they come back during an earthquake, it's going to be really difficult. So we have CERT teams, and I'll talk more, maybe a little bit about that. So this is just some pictures from our last workshop. So we had a large number of mobile vehicles show up, because what's happened is instead of having large emergency response buildings, bunkers, more and more they have these mobile equipped vans. So we had like a little rally, and they brought in. And of course, big issue there is they've got different communication standards, they're using different technologies, they can communicate by voice finally after the 9/11, there were a lot of issues. Now you can have voice communication, but they still can't have data interoperability, big issue. And this is another one of these characteristics of how things get funded. They like to fund stuff. Have a nice shiny new van, you can find money for them. For the software, well, we'd like the software free, please. That'd be interesting. This is a ham radio group sort of working together, and I actually, what this triggered for me is that I had to become certified to do something myself. So I did ham training, so I'm now certified ham, 2nd level. I also did a CERT training, Community Emergency Response. You'll see a picture of me in my little green jacket. And then we also got a donation from NASA of some trailers, which we equipped with solar and Wi-Fi and radio, and this is inside as our own mobile emergency response vehicle. Challenge is power management. So you want low power radios, low power displays, everything low power, solar power, batteries. So you learn other stuff. It's one of these integrating areas. So the challenge that we see, the vision of this, is the problem of coordinating, collaborating, and aggregating information. Because of the advent of mobile phones, and we saw this in Haiti, more and more information is possible. As people say, a picture is worth 1,000 words. Except a friend of mine at the police force said, I don't want 1,000 words, I want 3. Fire over there, something like that. And so the challenge is to get more and more information, and now boil it down using machine learning, information retrieval, big data techniques to the essential information. And then you've got to get that information, either notifications or coordination, to the emergency responders, who may be professionals, who may be semi-professionals, or as they call them, SUVs, spontaneous untrained volunteers. So this just-in-time training information, going all the way to what's increasingly become mobile command centers. So what happens is a whole group of them show up, and that forms a little, it's like a Burning Man community. You have the fire, you have the Red Cross, the Salvation Army, they've all got their own trucks, they all show up. And so that's kind of the space we're working in. So we've realized it's much bigger than we thought. Now, one of the challenges, and this is part of what got me into the radio stuff, is if you think about all the participants, every one of them uses a different mechanism for communication. We don't have a single ubiquitous thing. Ordinary citizens are beginning to use cell phones, or SMSs, or Facebook, or Twitter. That's how they like to communicate. And they have to call into a 911 dispatch center who doesn't use any of that stuff. They just like a phone call. They are not set up to use it anymore. The professional responders use what's called land mobile radio. These look like small portable radios, but they use special encodings and frequency agile activities. Here's CERT teams, and that's me wearing my little white hat. The fun part was actually learning how to put out a fire using an extinguisher. There's ways of doing that. And then the other fun part, less so, was to go into a dark room and find bodies. And the idea is you kind of walk with your hand on the wall. It would be nice to have some kind of sensors that I could use in the dark. The idea was, one, you shouldn't be afraid, well you are. Secondly, you shouldn't step on the bodies if you can avoid it. So that was the training. But so you get some training. Well, these guys use amateur radio, what's called field radio service, or sometimes GMRS, General Mobile Radio Service. The various NGOs, like the Red Cross, use the radio and mobile radio. And then we have the operation centers, and then you have these big guys who get involved. You know, if you need water, where do you go? You go to Walmart, or you go to Costco. They're the ones who have crates of water. If you need things to fix buildings, you go somewhere else. So the challenge was, what do you do about all of this? Now the fact is, everybody's carrying a mobile phone, including firefighters. Yet they don't use that in emergencies. The question is why? Well, part of the reason is battery. You know, you use my ham radio, the battery is a big honking battery that will last for a long time, while my cell phone, if I get a day or two, I'm lucky. That's one problem. Second problem is cell towers. Almost always something happens to the cell infrastructure. If there's a big fire, like San Bruno, if there's an earthquake, the cell towers go down and people can't communicate. So these guys are carrying the big radio and a mobile phone, because a mobile phone is better for most communications. You can see pictures on it in a smartphone. So we said that's one of the problems we wanted to look at. I'll talk about it a little bit. So here's one example of a project we did just for your entertainment. This is a firefighter using a turnout code. It's a big, heavy code. We sewed a pocket onto it, and we've got a mobile phone in there that he can operate. Now, one of the things you find out, and you stupid should have guessed it, when you're wearing a big glove, it's pretty hard to press buttons on a mobile phone. So we ended up doing things like this. It's a big, fat button. You know, what do you have to do? Danger, get out, kind of thing. The buttons that are big enough so you can do it with a phone. We also tried using one of the small pads, not a full iPad, but like a mini iPad or something else. It's too big to fit in the glove. And the guy's not going to pull a phone out. So we haven't yet found the right form factor that uses mobile phone technology and the smartphone capabilities that can be used. This is a fireproof pocket. You can get something that's transparent, but pretty reliable. So this is just one project we did, and this uses SMS as the primary communication vehicle. This was shown internationally as well. So the idea here is, our project was, we may have cell phones, we may have enough battery left, but the cell phone infrastructure inevitably is either overloaded, you know, congested, or totally compromised, or won't come up for a couple of days. Even San Bruno, which if you think of it as a relatively small disaster, knocked out the cell infrastructure for, it was about a day. So what we want to do is tie these things together to something we're calling Silicon Valley Resilient Network. And the idea is, at level one, the phones just work with each other, so we're going to mesh them together in some way. Then we will have a very limited internet connection, probably satellite. And satellite is very narrowband. And if everybody's trying to use it, you get very little. So you need to prioritize messages and packets. And then finally, the neighborhoods can sort of be linked together. For example, Palo Alto has unused dark fiber. And that's pretty reliable under most circumstances. Could you tap into it? So that's kind of the framework. So the prototype we built ties all these bits and pieces together. We have something called a survivable social network, which uses cell phones communicating just with each other. And then there's a gateway up to some server, and the server can be local or global. We have a mapping wall that we can put information from the phones up. We tied it into one of the mobile vehicles, and while we haven't done this fully yet, we are deploying some sensors that are going to feed information in as well, temperature, light, you know, these things you can do. And the idea is to create this environment. So I'm going to just touch on a few of the pieces. So the survivable social network is to focus first on the communities. So what we built is an extremely minimal social network that, you look at it, it's like any other social network. Very quickly you can figure out how to use it, except it runs totally on the phone and on a very small server that can be one of the phones. So it's a social network in a box, which means a CERT team could carry one of these. It could be in my house. I can build it on a laptop. We can distribute them around. It feels like a regular social network. You don't install anything. It's all HTML5. It needs no training. It needs no training because we're all trained already how to use these things. social network, I know what that is. I can communicate with people, I can find out who they are. It's very minimal infrastructure. A laptop or a small server, it's a Wi-Fi access point, you build it yourself. It's all HTML5, except for the void. We're still trying to figure out how to do that through HTML5. Right now we have to download a small SIP server to do that. It uses Elch, which is a social net, an open source social network framework, asterisk for, it's a little PBX basically, and SIP. And the other idea is, we talk more about, maybe I'll talk more about that. Even though it's a standalone social network, we can use it to interface when the world is running to your Facebook. So it can clone pieces of your information if you want. So when the world goes down, you have most of what you have. It means I don't have to enter into it your name, you know, my friends, and various other things like that. So one of the experiments in that space is what we call semantic geotagging. Are there ways of using a phone to give somewhat structured information back to people in the community without having to type a lot of stuff? And so the experimentation here is a combination of map, a very simple, if you like, metadata structure, you know, including those, you remember those big red buttons we showed you before, you get an alert and all clear. Do we want to describe the situation? Is there a problem report? And then we can add things. And we're still experimenting with it. It's a real tension between having just a small fixed keywords, which aren't descriptive enough, having a few little fields where now you have to type or speak, and that's a problem, because in the field there's something's going on. So the place we think this is going to be most useful is for CERT teams. The CERT is the Community Emergency Response Teams. What they do in a disaster is you go around the neighborhood and you do what's called a drive-by survey. You look to see if a building has collapsed or not, if there's somebody's put up a green or red sign, I need help, and you quickly enter that information. And that information collects to a little local node, which is then distributed more globally to the emergency response center in your city, who then decides how to distribute the 3 or 4 fire engines they have available. So that's the problem. They have to decide very quickly how to prioritize limited resources. In the meantime, you have to decide, can you help your neighbor? So what happens is you fan out and collect information. Today, people do it on paper. So walk around with a clipboard, and I'm walking down, you know, Isabel Street, and that house is okay, that one looks bad, I smell gas over here, et cetera, et cetera. Then I walk back to a small central place, give them this piece of paper, they enter it, compile it, ship it by amateur radio, generally, back to the central office. That's very slow. But in those disaster response times, people don't want to use mobile phones because of the reasons I told you before. So if we're able to tie it into our mobile social network, survival social network, then we can use it. The other side of the coin was experimenting with how do you take data from all of these mobile phones and show them on maps. So we've built a variety of small hyperwalls. It's interesting, within 3 years, this hyperwall looks old. It looked very interesting 3 years ago. Now you can get these things with no bezels at all. But anyway, the main idea was, how do you put maps out, share them between multiple systems? So this is one system, this is another system. This could be the command center, this could be the local one. They actually share the maps using HTTP over something like the survival social network. And then there were 2 experiments on how do you interact. Since we're all using mobile phones anyway, can we use the mobile phone as the mouse? So you'll see this green one is moving that icon, the blue one's moving that icon. When you put it over an area where you think something's happening, you can press a button. In theory, not quite work the way we thought, you can call the person at that location. Not by name, but by role. And that's kind of context-aware, situation-aware activity. We also experimented with a Connect to see what that was like, whether you could move things. It's not fine-grained enough, so we ended up not using that. But the key idea is that this map then holds those little databases for interesting information, which means you've got to tag things with context. And where does the context come from? The local person, either because of their role, if it's the local field commander, his information is obviously more relevant than some random citizen, or at least that's one strategy for prioritization. So the priority information gets sent first. If the network is compromised, and I have a PhD student working on different ways of taking messages and prioritizing them under scenarios of congested network, delayed network, and you'll see a little bit more of that. And then we do real-time updates, again using HTML5. You know, we can get messages, pictures, we can track things a little bit because the phone through the GPS will usually work under those circumstances because the satellites usually are not compromised by things happening on the ground. It's scalable, so you can run this on a little laptop. Just run through HTTP, any browser, all the way up to the big screen, and then you do this triaging. So what happens is somebody in the local display can press a button and say, this is important, that's all that's needed to escalate it up to the next chain. And I want to do that on my phone. I want to be able to do it on any device that I have available. I mentioned our little next-gen emergency operations center, so this is an example of what that is. It's the trailers. We discovered actually using very big QR codes is a very interesting way of communicating using mobile phones. I just come up and say, oh, that's what it is, look at the just-in-time training. If you go inside, we've got smaller QR codes on the devices. Remember, you can do all the training and planning you want. When the disaster happens, you have no idea who's going to show up. Whoever is around at the time will show up. You want to make things easy to use, accessible using the typical devices that you use. Solar power, this is an experiment. We're part of a group that has a community Wi-Fi set up so that you can use long-range 802.11 if you use focused antennae. So you can set up a little backbone which is part of that survival social network. For a while we were partnering with the state KLEMA, and they loaned us a satellite communication vehicle to link into that. Here we have people sitting inside actually doing a wildfire monitoring exercise. So that is, from this trailer, they were able to schedule flights, collect the information, and review it. So as I mentioned, all of this stuff kind of got pulled together. We had our third annual workshop in November, and the theme was making the smart communities resilient, using the network, mobile, social sensors, information technology in a full-scale demonstration. We integrated all this information. This is now the same map I showed you inside the Palo Alto's mobile emergency vehicle. And then here again are different people. One of the people operating in the vehicle, and here people setting up antennas to make this connection. So then we said, okay, what would you do next? How do we take more advantage of the mobile phone? And so the idea here is to look more at mesh technologies. So now we think about systems of devices, ranging from mobile phones to very low-cost gateways, which we're using right in the survival social network, maybe some laptops, that mobile base station that you saw, the larger one, although now we're trying to figure out how to build a small, mobile base station, cellular base station in a box, and then UAVs, which could be quadcopters, it could be helicopters, it could be something else. And say, imagine that's the same infrastructure you have, because that's what you will have. There will be flyovers, not all the time, but there will be some of those. There will be people with these things operating. How do we make this work? So the first thing we'll be looking at is smartphone mesh. How do we connect these? So this guy might say, I have visibility to a tower, I can connect, I'll be the gateway. And then these things have to self-organize. So we have a project trying to bootstrap the secure ad hoc mesh network for local communication. So this augments that survival social network by just having phone-to-phone communication, not phone to small server. Then the next step is, well, how do we handle delay tolerance? Because I might have a little cluster, we can communicate, but I've got an important message to get over there. How does that work? So what you will get is some UAV will fly over and, if you like, grab some of the information. Now what's making this possible is more and more of the communication is packet-oriented, HTTP, SMS, and less of it in this regime is voice-oriented. Although I could leave a voicemail, but I can send a few SMSs. They'll sit, with the analog of SMSs, until this guy flies over. It will collect the important packets, and that's why we have to prioritize them. I want the important ones to go through first, and then the other ones whenever. and then finally they get delivered into the larger infrastructure. And so the idea of the DTN mesh is phones mesh together, some of them gateway to the flyovers, and some of those gateway to the big server. And we are building and prototyping that. So in fact, what makes it interesting and difficult right now, it's a heterogeneous mesh, because not everything's the same kind of device. So we can't build one piece of software to do that. So we have a project, one of my colleagues is trying to make this work. We have a couple of PhD students working on, do we need a new protocol? Do we have easily downloadable things? Can you embed some of it in the stuff that is on most phones normally, and can you leverage that? Because you don't want to have to go and say, oh, I want to be part of this. Let me go to the website and download the app so I can do it, because that's the wrong time to do it. It has to be part of something else. And then one more project I wanted to touch on. Remember, I talked about the evolution into the Internet of Things or the social web of things. So the project we're involved with there is a smart community sensor network project. We're at NASA. NASA has, this is the artist concept, the building doesn't quite look as fancy as that, but they put together a green building. It's a LEED Platinum certified building. The building has something like 4,000 sensors distributed around it that monitor light and heat and when the windows are open. This is a very interesting building. It's got solar on the roof. It has mechanical shutters. Trees are planted to shade things. They have berms to collect runoff water. They have geothermal wells. I mean, it's a demonstration, top-end green building. And you imagine a smart community has some buildings like that, and then there's some buildings like the ones we in, which are legacy buildings, where you put up what's called lick and stick sensors, you know, stick it on the wall. And the idea is, how might we build a set of services and systems that do that? So that's what we're working on with the theme of energy management. And the energy management thing is, you know, when you walk into a room and you've got a light sensor, when you walk in, it detects somebody and then the light goes on. That's great for lights because there's almost no hysteresis between the time you detect the person and the light going on. You can't do the same for air conditioning and cooling or heating, because there's hysteresis in how long it takes to start up the systems, how long it takes the air to get to the room. So what you have to do is heating and cooling proactively. In other words, you have to know that somebody will be there at a certain time in order to do that. So what we're doing is we're trying to track the movement of either groups of people, named individuals. There's privacy issues, so we can't quite do that completely. Moving through the building, build up a flow model and know that that conference room is going to be heavily occupied 2 hours from now. And while many HVAC systems have programming, you know, Monday through Wednesday we'll turn it on at 7, we'll flush the CO2 out in the evening, and then the weekends we won't do that. Well, sometimes you have a public holiday. Well, people don't tend to program that. Or sometimes there's a big traffic thing, or sometimes there's a conference and people won't show up, or maybe you have a conference on site, people will show up. And you must have been at meetings where something's wrong with the air conditioning for your meeting, because it's unaware of the fact that you were going to be there. And so we're trying to build up a system that ties all these pieces together. Mobile phones then are a vehicle that help track people around the building. You can do that through Wi-Fi triangulation, and it's reasonably good. We've got a project in that space, and we've actually done it. The annoying thing with that is, no matter how hard you try, you can get to about 80% accuracy in knowing where people are. Trying to get it, machine learning, extra sensors, everything like that, it simply doesn't want to get above about 80%. It's good enough for tracking people in the aggregate. I can know, roughly speaking, where they are, but I can't tell exactly that you are in this room at this time. And the problem is, if I want to combine it also with calendar information and historical information, I need a bit more accuracy. So we're still working on that. We're going to try yet another approach. And GPS is wonderful outside, doesn't do so well inside. And even if it worked inside, it wouldn't necessarily get you down to a room. You know, you think the range. So there are a lot of technologies using time of flight, infrared, ultrasonic, Wi-Fi, Bluetooth, even faked out GPS. You can use those channels to do things. Everybody on Earth can't see all the satellites. They can only see their local satellites. So there's always satellites, channels that are not being used that you could potentially use. So that's kind of what we're trying to build now. It looks a bit like what we have with the mobile phones, but it's expanded in that we have sensors and actuators. This little cloud is meant to suggest fog computing. The idea is a piece of the cloud, a piece of the intelligent computation is pushed out as close to the edge as possible. You know, every time the accelerometer changes, I don't want to send that information to you. It'll swamp the network, and it's going to swamp the servers at the upper end. So what you try and do is push down a model that against which I want to know an unusual occurrence, a change that's outside of what my model says should occur. Only those things do I want to push up. So as these devices are getting more and more powerful, today we use Arduinos, which are Atmels, but you can use more powerful computing devices. We can push more and more down into these things. So you can use small Android devices. The amount of memory is available. So all of that plays together here. We use a campus network which is going to the cloud that runs servers, GPUs, agents to represent people, so I can run a mixture of a simulator as well as actual data. You know, I need to play out scenarios that might happen. So this is the kind of thing we're trying to build. What we've done so far is we have taken our building. This is me. This is a conference room. You know, this is the area. We've been placing sensors in every single room to sort of track. And we haven't fully deployed everything. We've got about 50 devices now around the building in several floors. And then each of them has 4 or 5 sensors on temperature, light, sound, infrared, location. And by combining those results, we've also started working with a group back in Pittsburgh called Sensor Andrew. They have a different device. So we're deploying some of those, and now we're into the heterogeneous network again. Because these ones were built by us using the Arduinos. The ones down in Sensor Andrew use Atmels that are programmed in a completely different way. So we're trying to use these in classes and our research. And what we hope to learn from that is, first of all, how much data you get. So these things try to send a packet of information using JSON every 5 to 10 seconds. So very quickly you can see how much data is accumulating in our server. It swapped our server after a short while. Now SAP is providing us a version of HANA, which is their high-performance in-core database, which we're going to use to see if we can handle this, because we will have terabytes of data very quickly. Most of it irrelevant. Most of it is more of the same. The other thing is, these things are notoriously unreliable. They don't all report when they're supposed to report. So they will report, and then the wireless network isn't good at that time. Somebody walked by and they blocked it. And so what you don't have is every 5 seconds you have time-stamped records, and the question is, are enough of them accumulating for you to believe a bit of sample, or do you raise an alert that you're not getting enough information? So you need a monitoring system that's monitoring the monitoring system. And so that's kind of what we're doing with that system. And now I just want to show you 2 or 3 other things that again involve mobile, kind of just wrap up. So here's our work on mobile location. People carrying a mobile device. So one of the problems is I can carry it, I can put it in my pocket, I can swing it around here. And so several techniques that we've been trying to combine, each one has got some issue. If I'm holding it stable and I'm not moving, you get a very good reading from the Wi-Fi. If I'm moving or shaking my hand or something like that, you get very strange readings. And so then you have to have a model of movement. So we have to take accelerometer movement into account while we're trying to do the Wi-Fi. So if the accelerometer is relatively stable, you trust the Wi-Fi. If the accelerometer is moving a lot, Wi-Fi is less important, but now you can do inertial tracking. So all of this is being combined to do tracking inside the building. So those red dots represent where people were moving in a particular snapshot in the same building. We pull that together. Context awareness is trying to understand the context of the user. We're interested in a variety of contexts. There's the physical context, where am I, how am I moving, who's near me. There's psychological context, which is much harder to get in, but you might be able to get because I can tell what I'm doing on the phone. Either I'm using it a lot or not. That means I'm interruptible or not. Or maybe I can tell that I'm working on one thing, and therefore I'm focused, or I'm just, reading emails. And then there's virtual context. I can actually look at the emails and messages received. I can check your calendar. So you want to take these streams of information to build up a context model, and then use it to build applications. And so the other part which I mentioned was, how do I build context-aware applications? So this is where, if you like, the product line has developed a set of components. We've built some components that can be run on multiple different devices that together can capture the sensor information, do some local fusing, pass it up to something else, do more fusing. And this actually is part of one of my students' PhD thesis. And the big issue here is resource management. You don't want to communicate if you can avoid it, because that uses up battery more than almost anything else. Reading the sensors all the time uses up battery. So you only want to read them when you think you need to read them, which of course is a challenge. You have a bit of a model that says, I'll wake up in 3 seconds again. It's like he wasn't moving, so he couldn't have moved very far. And I'll read the GPS again, because even reading the sensors. Now, over time, that is going to get better. But the physical limit of a phone, and this one is really doing 3 watts, is sort of the maximum power you can dissipate. So if it gets warm, it's hot now in my pocket, I can't send a lot of communication at the time, because I just don't have the power to do that. And then, of course, security and usability. And then finally, our machine learning or big data. So it's the modeling of human behavior. So as I collect more and more data, can I tell either what I'm doing as an individual right now, because of some exceptional condition, or can I predict some trends? And again, I'm using the mobile devices, the sensors. I mean, these are amazing sensor platforms. When you think about what's on them, GPS, Wi-Fi, accelerometers, light, sound. Some of them have compasses and cameras. All of that information is available, and if you send all of it, you'd blow the battery very quickly. So the question is, what do you run? And when do you run it? And then we use Bayesian and hidden markup models for prediction. So we do the sensor fusion, we do some combined reasoning, we can diagnose various things, and we predict this is the most important probability of future states. And you can use that to proactively turn on the heating, turn off the heating, provision a room for projection, encourage people to go meet in a different room. If you interact with the calendar system, and there are rooms, and this one's already nicely air-conditioned and that one isn't, don't go here, go over there if it's available. So you can see how all that fits together. So this is a short summary of some of the R&D issues that we're grappling with. This now applies to the general question of the mobile enabled systems. You've got to make these things robust and easy to use at the same time. We've got to understand the software engineering methods for these loosely coupled systems. And the loosely coupled combination of services, mobile sensors, cloud, gateways, fog, agents, all of these. As I mentioned, the Bobby case that we started a couple of years ago had a workshop associated with it, which was called the Workshop on Mobile Software Engineering. And we were trying to tease out some of these issues. We've run 2 sessions of it, and then it's recently, we're not doing it this next time. Bobby case will be this next time in Paris in November, which apparently I'm not going to go to because my first grandchild is due exactly then. So it's too bad after planning it. But also, another mobile workshop has started up, the D-Mobile, which is yet another group. So what's actually happening, we may have this as a challenge to a community. How do all of these mobile workshop groups somehow work together and not be fragmented just like their regular mobile thing? Because every one of them is asking roughly the same questions, but they're not combining their wisdom. So you will do your brainstorming, and hopefully I'll be here to do this brainstorming something with the cards. How do we leverage either what the other workshops did or contribute into the next workshops? How do we get these things to be affiliated together so we don't have 16, 10, I mean, they're just popping up all over the place, and they all see the same class of problem, software engineering. How do we push the computation to the edge? What is the paradigm that says this thing that I can do here can be turned into a recipe that I can push down? Naming and directory services, how do you find things in this world? You know, even OpenID is not going to be enough for this activity. You've got to manage the scale, distribution, installation of these things. When we started deploying these sensors, we suddenly realized, oh my God, we're going to have these all over the building. Somebody's going to have to replace the batteries. So we cheated. We took away the batteries and plugged them in the wall. So we've gone backwards. But we've got to figure out how to do that. You know, either we've got to dynamically monitor the battery power and have a model that says like you do sometimes with lighting, proactively replace the batteries, or we need to use less battery, or we need to have better batteries. All this will happen, but right now it's a big problem. Secondly, I walk into the room, I do a lick and stick, put it up here. Well, how do I know that that sensor is in this room monitoring this stuff? How do I name it? Do I then have to sit with my phone and interact with it? Does it have a QR code on the back and I scan it and type something in? Because I certainly don't have locationing working well enough yet, because that's part of what's going to make locationing work. So that's part of the thing. And then you've got this mix of devices. So what is the network management mechanism? This is just some. I'm sure we'll come up with others and decide that maybe this is the most important, that's not important. And I don't know. I'm hoping will come out of this workshop is, and here's the project we should work on. It wouldn't be nice if we could find one thing. Last thing is, here's some of the companies we've built up relationships with here in the Bay Area since we've come. Most of whom care about the mobile life, if you like, the digital lifestyle. You can see, you know, security on the one hand, networking. Don't really have to say much. I mean, and exciting is being in Silicon Valley, how easy it is to make connections. And if we can use our presence here in conjunction with some of you to work with these folks, that would be really great. With that, I thank you, and if you have any questions.
Thank you very much. We have to have lots of questions. Oh,
Let us start.
sure. Questions from somebody who's not Henry. It's you, Henry.
Okay. So, you know, the earthquake topic is very touch-feeling for us. And we had a big earthquake in Latvia 4 years ago.
Yes.
And we are still trying to get through it.
Yes,
It's
recovery takes forever.
Still starting. So that's very, and I know that there is this initiative, Smart City L'Aquila,